Hello friends, welcome to Code Sutra. In this video, we will be solving LeetCode problem number 530, the minimum absolute difference in a binary search tree, also called as BST. So what is a BST? A BST is the one in which the left subtree is always lesser than the root node and the right subtree values is always greater than the root node. This is the root node and this is the left subtree and this will be the right subtree, and all the values that are on the left side will have a value lesser than the root node and all the values on the right side will have always value greater than the root node. This is true for any given node. So if you look here also the left subtree, that is 10, is lesser than 20 and the right subtree 30, that is 30, is greater than the root node. So what do we have to do here? What we have to do here is we have to find the minimum difference between any two given nodes. For example, what is the difference between this node and this node? The difference between these two nodes is 3. But if you look here, what is the difference between this node and this node? The difference is 1. So you have to find which is the minimum absolute difference between any given two nodes in a binary search tree. So the answer in this case will be 1, which is between 2 and 3 and also between 1 and 2. So how do you find out this? Now we know what is a binary search tree and also what we have to do in this particular problem. So now let's understand the concept of inorder traversal. What is inorder traversal? Inorder traversal, as the name indicates, you first travel the entire left subtree and then you come to the root node. Then only you go to the right subtree. The order is left, the proper root node that we have now, and the right subtree. That is, this is in order: left, the current node, then the right node. So what is the advantage of this? So if you look here, this will always be in increasing order. So if you do the in-order traversal of this particular tree, where do we go? First we come to 20 because the left subtree. Again we go to the left subtree, that is 10. The first value will be 10, and if you look here, this is the minimum most possible value in this given binary search tree. Why? Because we came left, and the left most node will always have the minimum value. Then we will come to the root node, that is 20. Again if you look here, this is the second value, and again if you go, it will go to the right subtree, that is 30. Then we will go to 100. Then only after finishing all this, we'll go to the next subtree, that is, we'll print 150, 200, 300. So if you look at this, this is in increasing order. Why is this even in increasing order? It's because of the fact that the left subtree is lesser than the root node and the right subtree will always be greater than the root node. And if you look here, the minimum absolute difference can occur between any two consecutive elements, right? Why? Because the difference between 10 and 30 will always be greater than the difference between these two elements. So once we have this, the key idea is we will keep a previous value and we will keep the answer. These are the two global variables that we'll be tracking. So once you go to the in-order traversal, the first previous value will be 10 and our answer will be initially infinity, and this previous will also be infinity. So we go to 10 here first. Then once we come to 20, what we do is we subtract it from the previous value, that is 10, and we will update our answer. If this answer is lesser than the original answer, we will change this answer to 10. Similarly, again we go to the next, that is the right subtree, that is we are doing in-order traversal. Again, don't forget we have to update the previous value to the current node. Now our previous value will be equal to 20. Then once we go to 30, again we will have the same answer, that is equal to 10. So that is how we do at every step. Now let's dive into the code and understand the time complexity. So if you see here, we have initiated the previous value as well as the answer. Both of them will be infinity initially. Then what we are doing is we are calling in-order traversal and finally we are returning the answer. So within in-order traversal, if you look here, we are doing the calculation in between, not at the start, not at the end. Why? Because it is in-order traversal, and as the name indicates, you have to do the calculation or anything in between. So that is the key idea. And also it is intuitive to do the left subtree first. Why? Because if you look here, only after the left tree is complete, you will get the maximum value in the left subtree. For example, 30 is the maximum value in the left subtree. only then you will get the difference, right? So that is the key idea here, to do the calculation in between. Then again you will call the same thing on the right subtree, and prior to that you will call on the left subtree. So if you look here, what is the time complexity? The time complexity, we will reach every node just once, so the time complexity will be order of O of n. What will be the space complexity? Are we using an extra space? No, right? So the space complexity will be O of 1. So thank you for watching the video. Please do like, share and subscribe.